Hello, everyone. Nice to meet you. And this is Yuwu Chen from the TSCC User Services Group. And I'm very glad that we have our new TSCC 2.0 available soon. And now we are in the testing period. So today we are having a TSCC 1 to 2 transitional workshop. And again, welcome, and I'm very glad that you're here. So what do we have for TSCC 2? Here is a general architecture overview. We are buying lots of new hardware, including the storage, new storage home and the larger file systems. We are also buying the new internet switch, and we are having a new job scheduler called SLURM. As you may already know, this is a very popular job scheduler, which will be our new job scheduler for TSCC. And we also have a Bright Cluster Manager. This one is mainly for the system admin to manage our nodes. So probably you won't have a chance to use it, but we will have a new cluster manager. Also, we have a new operating system called Rocky Linux 9, but still the environment is the operating system environment is Linux and Bash by default. And we also upgraded our environment module, compilers, and software, and we will take a look at this in detail later. And this figure shows that after the moving, we still have a condo cluster and a hotel cluster, and then but for the testing period, we are mainly focused on our hotel nodes as a part of the test cluster. And you see, we have added lots of new stuff, including the new software, hardware, and the middleware. But we are trying to help you as the whole TSCC team is still the same, but we are getting older and more experienced. So we hope with that you can have a better experience when using TSCC 2 than before. So what to expect from today's workshop? The goal for today is we are going to introduce the TSCC 2 test cluster, and then I'm going to provide more information about the transitional from the current TSCC 1 to 2, and we also include how you can better transfer your data from TSCC 1 to 2. And please note the overall TSCC 2 system is still in the process of being upgraded and enhanced. So keep an eye on our coming user guide, and many stuff that will be upgraded, and maybe something will be different from what you learned today, but yeah, we will try our best to make sure that we are presenting the most up-to-date information to you in today's workshop. And also we have some system and policy changes for TSCC 2.0. And if you joined our two previous workshops earlier this year, you will find that in today's presentation we have changed a lot of stuff, and so that's why we are inviting you to attend our workshop today, and please pay attention to today's material in the workshop, and maybe you will find something you haven't learned before. Of course, your feedback is requested, and after using our systems or if you have any questions or comments, please let us know, so we can know we can know what you are thinking of our new systems, and to see if we can make any improvement. Okay, before we start the talking TSCC 2, here is the acknowledgement. So the TSCC 2 new hardware is supported partially by the TSCC funds and mostly by our center director Dr. Frank. And we also thank Dr. Ludmil Alexander for his contributing of the new some new notes to the hotel program, and we really appreciate the support from them. Thank you. So let me start from the beginning. Now this is this is the beginning of the today's training slides. Here is what we are going to learn today. First, we will talk about some system overview and how to log into the new TSCC tool. And then I will mention some details about the allocation systems, which we couldn't add it into our previous TSCC2 workshops. Now we have made some significant progress. So I would like to introduce our new allocation system. And then it is for the file systems 2.0, which will including the introduction of the new file systems, as well as how to transfer your data to the new file systems. And we will then cover the software environment about using the new module. And the last but the most important part will be how to use SLURM to submit and manage jobs, which will including the new job partitions and the QoS. QoS is a new part of which you might not use before or under the current PBS job scheduler. And then I will talk about how the jobs be charged by our new SLURM job charging systems, and then how to submit and monitor SLURM jobs. Okay, let's go to the first session, which is about this system overview and the login. And maybe some of you are new to TSCC or never attended TSCC 101 trainings before. So here's just a quick review of our TSCC programs. So for the TSCC, we have two programs, condo program and the hotel program. And the condo users are purchasing their nodes and add them to the TSCC cluster. And so they can use condo nodes as well as the hotel nodes. The hotel users are purchasing computational time, and once they made the purchase, they are giving some credits in their allocations and for them to use the hotel program. So that's the base of the TSCC operations. Now after today, we will open a TSCC2 test clusters for all of our TSCC users. The test clusters is mainly focused on the hotel nodes. That means we will open many hotel nodes for you to test and get familiar with our TSCC2 systems. At the moment, we have 30 CPU nodes plus 1 GPU nodes in the TSCC2's hotel program. And we are adding more CPU and GPU nodes in the future. And how about the condo nodes? And we anticipate that the testing period will last for months. And maybe during this month, we may add some or all of our users condo nodes in batch. So it's likely many of the condo nodes will also be available during the testing period. But we value your feedback, and during the testing period, please let us know your feelings, your comments, so we can know how can we improve our cluster. So on TSCC, as you may already know, we need to assign account for each user. for each user, their account might be a condo or a hotel account. For those new users who would just like to try TSCC, we will give them a trial account which valid for 90 days. Sometimes we will assign some training accounts for different purposes, including the workshop, different workshop, bootcamp, or tutorials when they are using TSCC. But please note, today's TSCC transitional workshop. In this workshop, we do not provide any training accounts, so we expect that you can use your own accounts to try TSCC in today's workshop or during the entire testing period. So how can you get a TSCC account? Yeah, just some basic knowledge about how. Please send your account request to us and with your full name, institutional email address, and the group lab name, and we will confirm this with your PI and then create an account for you. Okay, so next, how to log into TSCC now. We have a new host name for TSCC2, which is login.tscc.sdsc.edu. So please, when you're logging from Linux or Mac OS, you can use the SSH command on a terminal to this host, and then try to the next process. If you are a Windows user, I'd recommend that you download a mobile system and then log in through the mobile system, still with the same host name. Now the authentication part is different from the last workshop or from before. And you need to log in with your account, TSCC account, plus your UCSD AD password, plus the Duo. Duo is a two-factor authentication method. If you are not a UCSD users, we will get a UCSD AD account for you to log in. Still, when during the login, you need to enter your TSCC account plus the UCSD AD password plus the Duo. So this is the command, how the command login command looks like in the Linux and Mac OS. When your terminal is open, you can type the SSH command, then your UCS, then your TSCC account, then add the host name, login.tscc.sdsc.edu, and then enter your UCSD password. Now, next, the dual authentication process will begin, and you have a choice to choose the dual push or receive a SMS passcodes. And I also added a link here for you to get familiar with the dual. So you can once you have your AD account and password, and you will be able to log in TSCC with your AD password plus the Duo. And if you are using Windows on your local machine, you can download a mobile system and then start it from a terminal or from a new session, as I highlighted here, and then you can just finish the login process by entering the host name as well as your account name, and then choose to connect, and then the password, you enter your AD password and the Duo to log in. Okay, here, this is all about the login part. So any questions about the login and our system and TSCC account, or anything you wish to know before we move to the next session? Okay, so I'm going to talk about the allocation. So this is a new part. of the we made some important progress recently, and I would like to share with you how the allocation and system works now for TSCC 2. So as a reminder or as an introduction to the new TSCC users, what is an allocation? So allocation is a block of service units, we call it SUs, that allows a user to run jobs on a supercomputer cluster. That's the definition of allocation. And the TSCC jobs need to be charged to a valid allocation, including the hotel allocation and the condo allocation. But now, please note the SUs under the TSCC2 is based on minutes. So in today's workshop, on my slides, I will just show the SU in minutes. So before on the TSCC1, the SU is based on hours. In today's workshop, I will mark it as SU in hour. So just try to differentiate those two different two SUs. So why we are doing this is mainly for better credit your allocation or charge your jobs. So now the job is charged based on the minutes. For example, your job was if your job is has been running for 5 minutes, then we will charge you 5 minutes of SUs under TSCC2. But before, we will charge you for at least 1 hour because it was based on one the SU was based on hours. Okay, so another difference about the TSCC allocation is now the TSCC allocations are based on the purchase type. Let me explain what's going on here. So we know we have a condo users and hotel users on TSCC. The condo users purchase nodes, and then they will get a condo allocations for them to use or run jobs on the condo nodes and the hotel nodes. So that's the same as before as TSCC1. Later, if they are running out of SUs in their condo allocation but wish to keep using TSCC, they can purchase new SUs and add it to their allocation, but not to their condo allocation anymore. They will get a new hotel allocation for saving those computational time they purchased, and they can use the new hotel allocation to run the jobs to the hotel program. So how about the hotel users? We already know that the hotel users will get a hotel allocation, and the allocation is only used for running jobs on the hotel nodes. If they later decide to purchase nodes to join the condo program, they will become condo users and get a condo allocations. Then they will have two separate allocations. One is for their one is their hotel allocation, and another is a condo allocation. So that's we don't mix the condo and the hotel allocations anymore. So we are separating them because that's for better allocation management purposes. Okay, so let's take a look at the hotel allocations. So there are some base features about the hotel allocations. We're keeping this since TSCC1. So the hotel allocation can be credited at any time of the year. It's a pay-as-you-go model. You can choose to get by SUs and add them to your allocation at any time of the year. What you have bought can be rolled over every year. But now, as I mentioned, the SUs are based in minutes on the TSCC2. So, for example, for UCSD affiliates, a minimum purchase of $250 will get you 600,000 SUs. But just know these SUs are in minutes now. You just multiply the 10,000 in TSCC1 by 60. Now you get the new SUs amount in minutes. And of course, your current TSCC1 SU balance will be carried over to TSCC2. And we will after we make this ready, you will find that your SUs and your TSCC1 SUs are multiplied by 60, and then you get a new number in TSCC2. Okay, so the next but more complicated situation is the condo. As we already know, the condo credits are added manually for the duration of the MOU, and there is still no rollover of leftover SUs. That means your SUs in your condo allocation cannot be rolled to the next year. But there are several significant changes under TSCC2 now. Of course, your current SU balance will be carried over to TSCC2, and the units, but now the SU is in minutes, of course. There are several significant changes about your condo allocation SUs. I listed here. There are three major differences now. First is about the annual credit date. On the TSCC1, the SUs will be credited at the beginning of the month when the nodes were added to TSCC. So that means we will have multiple time to add condo allocations every year, and even for the same group, we sometimes we were confused about when to add your credit to your allocation. But now on the TSCC2, every TSCC condo group allocation will be credited on the first Monday of September every year. So that's the single day. And under TSCC1, there's no such credit first. We just added the 4 year of the credit to TSCC1 when the node were first added to TSCC. But under the TSCC2, since the date of the credit addition is fixed, so now when your nodes were first added to TSCC, they are prorated for the first year and the last year. And the last part is about how to get the SU allocation, how many SUs you will get. For TSCC1, the formula is relatively simple, and you can just get to know the total number of the CPU cores you have times the 24 hours times 365 days, and then times 0.97 as a downtime maintenance time. But for the TSCC2, the formula is more complicated, and I will list the formula here. So we will divide, we will consider several parts of your hardware into this formula. First is the total number of the CPU cores, and then the total memory of the nodes in the unit of gigabytes. And if your node comes with GPU cards, we were also considering to credit your GPU cards and add them into this formula, and then we time the number by 60 minutes, 24 hours, 365 days, and still 0.97 uptime. So here's an example. So a researcher has bought a TSCC node, which is a 64-core, 1 terabyte CPU node. And then we added to TSCC 25 days before the next 4th Monday of September. So how many SUs this node can get? So here's the equation. Is actually once we get to know how this works, it should be still straightforward. So when the node is first added to TSCC, it will be considered as 64 cores as well as 1 terabyte memory, and then we times the minutes, hours, days, and of course we only consider 25 days this time, and then we get the SUs in minutes for when it's first added to TSCC. And after that, every 4th Monday of September, we will get another amount of SUs, which I also listed here based on the formula above. And that's if of course if you have GPUs in your node, you can just add the GPU factor in this formula based on how the type of the GPUs, and calculate to and then get how many SUs your node will be credited every year. And please note the allocation names are changed on TSCC2. We're no longer using the same allocation name as TSCC1 because now the TSCC allocations are managed in a different system. So we are using the different allocation names, but here's the command as account manager for you to check your available allocations. So the syntax is as account manager show associate, and then you specify your username, and if you don't want the whole list, you can just specify to it the account and the user to let the command only print your account and the account and the username. Here the account is the allocation name. So in this example, my account has an allocation named use300. So that's the way you find your new allocation. And of course, if you are not sure, you're welcome to ask us. Okay, so now so far we have what we have changed about our allocations. Please let me know if you have any questions or comments before I move to the next session.
The question was, should the new login be working right now?
Yes, for the users who has the UCSD AD account, yeah, the new login should be working now. If not, please let us know, because there are always some exceptions or something wrong when we are moving those accounts. For the non-UCSD users, we are working on getting your UCSD AD account. We are talking about this with the UCSD IT, and once we have this done, we will give you the UCSD AD account.
Thank you. Another question has come in regarding yearly charges for Conda users, flat rate or according to hardware capabilities? Question mark.
So the Conda charging, let me. Oh, for the charging part, it's related to the type of hardware you are using. We are talking about the job charging later. I mean, the formula will be similar to the allocation credit, but it's based on the resources your job will use and how long your job will run.
Thank you, Yuwu. Another question is, do we need to be on UCSD VPN in order to log in?
No, as far as I know, we don't need, no.
Next question is, are condo charges one time only?
Condo charge, I'm not quite sure about the condo charge. I mean the condo allocation is a credit, right? I'm answering the users, and the condo allocation I just mentioned is about how many SUs will be credited annually. I mean, on each fourth Monday of September, you will be credited for those SUs until until the end of your MOU date. So that's how the SU can be credited to your allocation by the first time your node come to the TSCC, as well as the fourth Monday of September, as well as the last time the last year your node will leave TSCC. So that's not one time, but talking about the charge, we were talking about how we will charge your job under the new job charging system later when I'm talking about the SLURM job manager.
Thank you, Yuwu.
You're welcome. And any other questions?
Nothing further.
Okay. I'm moving on to the file system 2. And as I mentioned, we have a new hardware for the home and the scratch file systems. But here is the overview of our new file systems. For the home storage, each user will still receive 100 gigabytes of storage as the home directory. For the scratch, we have a new larger file system, and you can find that the path is different from the TSCC one now. The new path is /TSCC/larger/scratch and then your username. Of course, you can choose to add additional project storage from the RDS or from some resources we agree. And now please note, only the storage operated by SDSC can be mounted on TSCC2, and your current project storage purchased from RDS will be mounted to TSCC2. And another new feature is for the researchers working with the DBDAP data, TSCC2 will allow access to the DBDAP data on the TSCC cluster without isolating the nodes. So that's a good news for the researchers using the DBDAP data. So what we have exactly for the home new file system, please note after login, when you are in your home directory, the full path will be TSCC/NFS/home/user. If you echo your home environment variable, you will also get this value. And the home also have a 100 gigabyte of storage. And just note the home directory is for saving your source code, binaries, and small input files. it's not for the high performance I/O through output. Please consider to use the larger or local storage space instead. So about the data transfer, the data saved under the current TSCC1 home file systems should be transferred by the user. We are not transferring your data, your files under your TSCC1 home directory to TSCC2 because the main reason we're not sure what to transfer, and sometimes you will be the one to decide which and how to transfer. And I will give you some suggestions later, but it's your duty to transfer your files from the TSCC1 home to the TSCC2 home. And so far I know we are not mount the TSCC1 home to the TSCC2, so you will have to use some data transfer tools to transfer those files you need for the TSCC2. So about the Scratch, the new Scratch, now the new hardware has a 2 petabyte shared larger file system, and please note the new path is TSCC larger Scratch and then /user. And each user will have a disk quota in larger, but it's not implemented yet as far as I know. And still, please note there's 90-day purge policy on the files saved in Scratch. The Scratch system is good for the high performance I/O operations, but it's still not for extensive small I/Os. So if you have lots of hundreds or thousands small files opened at once, please consider to use the local Scratch space instead. So still, we are not moving your files from the TSCC1 larger to the TSCC2, and it's your duty to determine and then move those files to the TSCC2 Scratch directory. Besides the home and the Scratch, we also have a projects directory. Please note the new path is /TSCC/projects and /your project name. Because this is not managed by TSCC, you should ask the SDSC RDS group for purchase or for management. If you would like to change your project directory, please reach out to RDS. And on the TSCC2, only a storage operated by SDSC can be mounted. And when will those storage be mounted? That's something we're doing right now, and some projects will be mounted to TSCC along with the counter nodes. And once it's ready on TSCC2, I will notify your group. And the next Scratch storage I would like to introduce is the local Scratch on each compute node, which starts from the Scratch /user/job underscore and then your SLURM job ID. This local Scratch is only available when you have a jobs running on that node, ranging from 200 gigabytes to 2 terabytes, depends on the node type. The local Scratch is very good for writing small files, but please note that what you have written there will be purged at the end of running jobs. And here, just a reminder that we might mount the current TSCC1 larger file systems on the TSCC2 for data transfers, but it's not ready yet. We are not mounting the home TSCC1 home storage to TSCC2. So you will need to use some data transfer tools to transfer your files from TSCC1 home storage to the TSCC2. And next, I'm going to introduce some advice or suggestions and tools how to transfer data from the TSCC1 to TSCC2. The first, but the most important thing you should determine is the what files you would like to transfer. Please only transfer necessary source code, input output file, portable programs such as the singularity images, and before the transfer, you can back up your data to your local storage just in case if something went wrong during the file transfer, you can still recover them from your local storage. But please consider not to transfer any previously compiled softwares, including your Anaconda, Miniconda, and Member. Those are not a good candidate to transfer. Maybe I think you should reinstall them on the TSCC2 directory, and please don't transfer unwanted or temporary files. Same for the version control reports, such as Git. You probably can start a new report or get previous reports from the Git directory rather than copy your current reports from TSCC1 to TSCC2. So please think carefully about what files to transfer, especially if you have hundreds of gigabytes or even terabytes files to transfer. So that's very important. And of course, let us know if you need help with the file transfer, or if you cannot decide which files to transfer. We can take a look with you and help you decide. Okay, so next I am going to briefly introduce several file transfer tools from SCP, rsync to SFTP. So those files are very common in use when transferring files, and they are available on TSCC1 and 2 nodes. You can just log into TSCC1, and please note, if you have hundreds of or thousands or millions of files to transfer, please consider to compress those files or directly into a single tar file instead of transferring many files at once. So that's you can use the tar command to make a large zip file before the transfer, and then you run the SCP command like this to transfer your files to TSCC2. Please note the destination is your TSCC account at the host name of the TSCC2, and you also need to include the destination path. If your file transfers are large, please consider to use the data move node rather than on the login node. So you can SSH to the TSCC-DM1, which is the host name of the data mover node, and then start your SCP command there. Once you have transferred the files you need, you can then log into TSCC2 and extract the tar file. And this is the tar command to extract the tar. Right. For the data transfer with rsync, the procedure is almost the same. You log into TSCC1 to see if you have a huge amount of files to transfer, consider to compress those files into one single file, and then you can run rsync with this syntax. Of course, if you have large file to amount of files or large size of files to transfer, please consider to use TSCC data mover node. And for the SFTP, is basically the idea is the same, and the slight difference is once you you run the SFTP, you can then go, and it's a file transfer model, and then run some SFTP commands within that file transfer models, and you can refer to its menu, SFTP menu, or transaction user guide for more information if you want to use SFTP. If you want to transfer your files from external sources, for example, from your local machine to TSCC2, still you can use those commands I just introduced. Or if you want to transfer, some files from a website, when the download link is available, you can consider to use the wget command. We will try to add globus for the file transfer to the TSCC2 Scratch directory. When we make it ready. And the last part is you can consider to transfer those files with GUI, which might be much easier for users who do not like command lines. So for example, in the mobile system, you can transfer files directly from its windows. And another tool I often heard from users is the FileZilla, and the FileZilla also works when transferring files from or to TSCC2. Okay, so before moving to next session, software environment, any questions or comments?
There are two questions, Yuwu. One is, how much disk quota is allocated for each user on TSCC 2.0's Lustre Scratch?
We haven't set it up yet, as far as I know. Maybe I haven't checked it for a while, for some days. But there will be a quota for that. Just for your information, for the current TSCC1 Lustre file systems, each user's quota is 23 around 23 terabytes. Yeah, we might or might not set similar numbers for TSCC2, but we will have a quota for that.
And the next one is from external to TSC 2.0, should we be SSH TSCC-DM1 node or login node okay?
So if you want if you want to transfer files from the external resources to TSCC2, at the moment we don't have data mover node on the TSCC2 side. Of course, I haven't checked this for days. Maybe I'm wrong, but my colleague can correct me if I'm wrong. But as far as I know, we don't have data mover node on TSCC2 at the moment. So you will not be able to use data mover node on TSCC2. Yeah.
And lastly, do we need to transfer all data from project and home directory?
For the project directory, you don't need to transfer data because the project will be mounted to TSCC2 directly, so that you don't have to transfer your files in projects. For the home directory, yes, as I said, it's your user's job to transfer data from their TSCC1 home to TSCC2 home directory. And please carefully determine which files to transfer. And let me know if you have any specific questions or need any help.
Thank you, Yuwu. That's all for the moment.
Thank you. Thank you. Okay, so next I'm going to talk about the software environment. So we still have modules on TSCC2, but the module is slightly different from TSCC1 now. So why there's different because TSCC2 use the error mode modules, which is different types of environment modules to the current TSCC1. So what exactly the difference is? So under TSCC2, not all the available modules will be displaced when you run the module available command without loading a compiler. Now there's a new command called module spider, which is important for you to see if a particular package exists and it can be loaded on the systems. And if you run that module spider with the application name you are interested, you can just use this command, and then you will get, in order to use the module you need, what else? What are the other modules you will need to load first? So that's what the module spider can show you. So then you know how to load the module you need, as well as its dependencies. And the module paths are different for the CPUs and the GPU nodes now. Now, basically for many software built by that have the module files, we have the GPU version of that software, and as well as the CPU version of that software, and then we created different module names for it. So when use the CPUs nodes and running softwares with CPUs, you might need to choose the module load CPU, and for the GPU nodes, you will need to use the module load GPU before you can use your software for a certain job. And we also upgraded the total software stack, and you'll find that we have a much newer GCC installed system-wide on TSCC2. And we also updated our MPI implementations and many programs under the new software stack. And I just listed several software using CPU and GPU. And it's worth to mention that the most packages are built by SPEC. Now, SPEC is our software build tools to build software system-wide and generate the associated modules. And here is the slide to create your own module files. Actually, it's the material is the same as the TSCC1. You can still choose to create your own module files on the TSCC2 as long as you know how it works, and then you can, once you created a module file like this and saved it in your own space, you can add the path to the key to the environment variable called module path with the export command, and then you can begin to use your own module files. Okay, this is about the new module files. As in this session, we don't have too much changes about how to use modules. Like you want to load module, you still use the module load, and you want to unload or purge, the command will be this almost the same as the TSCC1. So I didn't add those stuff to the slides, but you're welcome to try the new module files and let me know if you have any questions. Next, we are going to learn the most important part of TSCC, perhaps the most important part for you to run jobs with the new schedule, SLURM scheduler, and we're learning how to submit jobs and manage jobs with SLURM, and what are the new job charging in SLURM. So we are charging your jobs in a different way, but we hope the job charging is much fairer than before. So that's the reason why we have a new job charging system. So as you may already know, the SLURM is very popular now on any HPC clusters. Before we are using the PBS, but it's out of date, and we are not keep using them. Now we're using SLURM under TSCC 2, and here is an important note for the test cluster users. Please note this workshop, as well as the following test period, is not for any large production runs for your research work on the test clusters. This is mainly because we have a limited number of computational resources on the test cluster. Right now, we have about 30 CPU nodes plus 1 GPU nodes, and only have 4 GPU cards on that GPU nodes. So we are limiting some resource usage, and I will mention this later during the testing period. So please don't run any large productions for your research work on the cluster. But on the other hand, as you may have noticed, that currently when running jobs on the test clusters, we are not charging you as used. I mean, from your allocation. So it's because it's still in the testing period, but still please consider not use only a small portions of our computational resources for you to get familiar with SLURM, for example, or for installing the software, having some small tests to see if your code can work on TSCC 2. After the testing period, we will open those resources limitations for you to run large production runs. Okay, so here's some job submission basics for the TSCC new users. And if you have been using TSCC for a long time, please also pay attention. Do not run your computational programs on the login nodes, even for some simple tests. There's some reasons behind that, but the main reason is the login nodes is for our users to log in. So you can use them for editing files, some simple analysis, and for other tasks that use minimal computational resources. But your large tests or some production runs will impact other tasks and the login activities of the other users who are using the same login node. So please do not run those programs on the login node. Instead, you should consider to submit a job for those purposes. So in the SLURM, they are partitions similar to the queues in the PBS job scheduler on the TSCC 1, but the SLURM partition is it's a slightly different from PBS queues. But generally speaking, it's also a set of nodes that a job can be scheduled on. So for TSCC2 SLURM configuration, the partitions for each job can affect the maximum job work time, also can affect the job charging rates. And I will introduce what is job charging rates later in detail. So you get to know how the job charging works under TSCC2, but the partitions in SLURM affects that job charging. So each partition will has its job charging rates for the SLURM job scheduler to calculate the right job right resources to charge. The partitions available for all TSCC users during the testing period are the hotel, which is for the CPU resources, and the hotel GPU, which is specific for the GPU resources. But only one GPU node is available at the moment with 4 GPU cards. In general, the partitions available in TSCC2 will be hotel GPU plus the gold platinum and several GPU partitions for the condo users. And please note those partition name might be changed, and you can use a SLURM command called sinfo to get an updated partition list. Here's the command and what's the output looks like. As you can see, the partition once you run this sinfo command, you get the partition name and whether they are up or down or joined or mixed, and how many nodes and the nodes list in each partition. And in this example, you can see that there are 30 hotel nodes in the hotel partition when I was running this sinfo, and there's one GPU node in the hotel GPU partition, which is called TSCC GPU 1-1 in that hotel GPU partition. And what are their stats? So the sinfo can give you more information about the partitions and the nodes. Okay, so besides partitions, we also introduce a new tool in SLURM called Quality of Services, QoS, to help us better manage and define the nodes and jobs. What is a QoS? So the quality of service QoS for each job to SLURM can also affect the maximum job work time, and it can affect the job scheduling priority, which also affects the job preemption and the job limit. And the QoS will be set for all group, every TSCC groups, and your group can have multiple QoS. And when you submit your job, you also need to specify which QoS to use. Now, during the testing period, you can use all TSCC users can use hotel and hotel GPU QoS. And for some condo users, you will begin to able to use the other QoS, includes the condo GPU, and the several QoS that's only available for your group. For example, the HCG is for the QoS for your group to use the gold node, the gold nodes, and the full name of that QoS is HCG dash, then your project name or your allocation name. And similar for the QoS using in for the Platinum nodes, and similar for the GPU nodes is HCA. And of course, condo users can also use the hotel and hotel GPU partition. Hotel and hotel GPU QoS. Here is the current partition and QoS configurations. I only listed a hotel and a hotel GPU here, including the maximum time per job, maximum jobs submitted per group, and maximum processor per group. But please note those numbers are subject to change during and after the testing period, and they are what I'm listening here might be accurate today, but they might change later. So to get the most up-to-date information of the partition and the QoS configuration, you can use some SLURM command. Here is the scontrol command to show more information on the partitions. In this example, if I run the scontrol show partition, I will get the partition information for partition information for all of the partitions, but I only listed the hotel partitions here, because the other partitions have the similar syntax and format. But here, let's look at this hotel partition output from the scontrol. We will get to know the partition name, hotel, and then you will find the allowed groups accounts and the allowed QoS. That's the allowed QoS for submitting jobs to the hotel partition, which is also the same name, but this one, please note, is the allowed QoS hotel, means the hotel QoS should be used when you submit your jobs to the hotel partition. And I also highlight the maximum time in red, which is 7 days in this hotel partition. But why I list one day? This actually is a 1-000. This is a 1 day maximum time, because this maximum time is also defined or limited, is also restricted by the QoS. So for the partitions, hotel partitions, the maximum time is 7 days, but later if you run the check out the QoS output, you will see that it's 1 day for the testing period. So you can submit a hotel job maximum for 1 day. Also, this partition node, hotel partition output includes the nodes currently in this partition, which begins TSCC 11-1 -2 -3-4 and so on. And the last line of this output, you will find the billing weights. Billing weights is something for us to determine how to charge your job submitted to this to these partitions. We also call it the charge factor. So you see we are having the CPU as well as the memory as our charging factor, and that's what I'm going to talk next about the job charging here. So we also have a job charging formula for TSCC2, which includes the charging factor of total CPU cost of the node per job and the total memory requested per job in gigabyte, and the total number of GPUs used per job. Then we times the job runtime in minutes and get how many SUs we will charge for the job running. Okay, this is an example. a researcher wants to run a job that requires 16 CPU cores, 32 gigabyte memory, and 2 A100 GPU cards for 120 minutes. So if this job finished at 120 minutes, this is the formula based on the formula above. This is the number of CPUs the job will be charged is 17,000 SUs in minutes. But if the job terminates earlier, only runs for 15 minutes. So we change the job runtime to 15, and we get that 2100 SUs will be charged. And in this formula, see the 16 is the total number of CPU cores the job is asked, and the 32 is a 32 gigabyte memory, and the researcher is using 2 A100 GPUs. We also include the charge factor for the A100 GPU card. Then we time the job runtime and get the final number of SUs in minutes to be charged. So once we know how the job charging works, we can begin to submit jobs. As we all know, the jobs here in TSCC are the interactive jobs as well as the batch jobs. So this is also the same in SLURM. When using SLURM, the interactive job can be submitted with the SRun command. So what is SRun command? SRun command needs many options, and I listed here some very basic and important options you should consider to specify, like the time -t is short for time. You can use the short option or the full option as you wish. And the -n is the number of nodes you want to ask, and then you can specify either -n, n is a lowercase n, which is short for n tasks, total number of tasks to run jobs on, or you can specify the n tasks per nodes, which is optional to the n task, but one will be override the other. If you are submitting multi-threading jobs, you can choose the -c instead, which is short for the CPUs per task, asking some number of threads per process to use. Of course, you can mix the -n and the -c to get a hybrid job. That's also fine too. And if you add -a, that is for the account. Account is the allocation name you want to use. And the -p is short for the partition, and -q is for QoS, and the -g is short for the GPU, the number of GPU card you wish to use. And also you will need to specify the memory you want to use for your job. I will give more details about the memory specifications in the SRun command. If you want to use the X11 forwarding, you need to add the X11 options, and the last part of the SRun is the what kind of shell you want to start for your job. So here's how the command line looks like in SRun. So SRun, in this command, I'm asking for one node, 8 total number of tasks, and I'm asking 20 gigabyte memories. Please note the default unit in SLURM is MB, megabyte in TSCC2. So if you wish to use memory in gigabyte, you need to add the uppercase G right after the numbers, and then 1 hour more time and submit to the hotel partition and use my hotel QoS, and then add my allocation name. And then the last part is start a batch shell. Once the job starts, you will find the node has been changed from the login node to the computer or GPU node. So once you see the node change, you know your job has started. And another thing you should pay attention is the job starts in where the job was submitted. This is a big change from the PBS job scheduler. For PBS job scheduler in TSCC 1, when your job starts, you will be back to your home directory, start from your home directory, and then you must choose CD to where your input and out data pool is. But under SLURM, when your job starts in where the job was submitted. So you don't have to change your directory anymore. Just another important note about running MPI jobs within with the interactive job. When your interactive job has started, you can use the another SLURM command to run your MPI executable and you can specify the number of MPI processes you want to use, but you must add the overlap options for MPI executables in the interactive job. Otherwise, the SLURM will hang. So that's only apply for the interactive job plus the MPI run. So for the batch job, you don't have to use this option. And also I have some example MPI executable prepared at the same shared examples SDSC TSCC2/MPI. If you run that, you can start an interactive job and then use the SLURM command to run the MPI executables there. But of course, you don't have permission to run jobs on the same shared. You can copy those code to your own space first. Okay, how about the memory usage? As you may have noticed, we now need to specify memories in our SLURM command or later even in the batch job command. You can choose not to specify, but now you also have the option to specify the memories. So here is here's the change that I listed, and from TSCC2 from TSCC1 to TSCC2. So under TSCC1, the default memory allocated to the submitted job is proportionally to the total number of cores present. So in that case, you should not specify memories in your qsub command or in your qsub job script. And we also don't charge your memory usage for under TSCC1. But now for the TSCC2, the default memory allocated to the submitted job is 1 GB memory per core. So that's the default value. That means if you don't specify memories in your job script or in your SLURM command, you will get 1 GB memory per core by default. And you should specify the memories based on your exact need. I mean, how many memories you should specify? So that's a very good question. Depending on your applications, it should be large enough to meet your program's requirement. Also, it's not wasting your computational resources because we are charging the memory usage on the TSCC2. Some small trail tests are always encouraged before any large production run. Why? Because you are encouraged to decide the best combinations of the CPU cores and memory usage of your production run. So you're not wasting your computational resources, and also you get enough computational resources to run your program. Okay, next is about how to submit a batch job. So here's a batch job example. You can just use the sbatch command to submit your SLURM job script. So all looks easy, but please prepare your SLURM job script carefully, because once it's submitted, it's hard to make any change when the job is running, it can even crash early because of some incorrect settings. I will give you several examples in the next few slides about how to submit SLURM job scripts. The first example is how to submit an OpenMP job. OpenMP job is based on the multi-threading. So I have the example scripts saved on the CMA shared examples, SDSC, TSCC2, OpenMP, and the file name is OpenMP-SLURM-SB. And in this example, we first define some sbatch sessions telling the job scheduler how much resources we will need. Here we define a job name, and then we're telling the job scheduler that we need a one node, one number of tasks, and 8 threads for running this OpenMP job, and then we decide how long we want, and give some paths to the standard out standard arrow files, and we also need to tell the scheduler the partition and the QoS name and the allocation name. And if you wish to receive emails when the job begins, aborts, or ends, you can choose to add the email options there. Okay, so after the green sessions, the next session is the session telling the job telling the SLURM how will you use those resources. So this is basically how to run your job. So in this example, I just purge the all current modules and then load the necessary modules I need for running this OpenMP job, and then I choose. I defined the OpenMP num thread to 8, so make sure I'm using 8 threads to run this OpenMP program, and then I just run the OpenMP to get my calculation done. If it's a GPU job, there are some minor changes I've made before the last. Compared to the last example I just showed. Again, the example script is available under the CM shared examples, and the example file is called amber-slurm-sb. Here I highlighted change I've made for using GPUs. For example, I highlighted I need one GPU's I need one GPU card, so I specify -G equals to 1, and I also specify the hotel GPU partitions and the QoS, and after this sbatch session, I just purge my modules and load the modules I need, and then run the Amber code in this example. And here's some note about the GPU usage. the GPU nodes on a GPU node allocation proportional to the total numbers of cores present. It's not this has been updated and it's not exactly right. But the next part is to use one GPU card on a GPU node with 28 cores and 4 GPUs. Then you should set the number of GPU cores equal or less than 7, but a minimum of 1. So that's the current up-to-date set configurations. So if you are using one GPU card, you can choose to use CPU cores either one of at least one CPU cores, but at most seven CPU cores when you are using one GPU card. And this only applies for the GPU nodes in the GPU hotel partitions during the testing period. And still these settings are subject to change. And they might be, it might be different, but we have some commands for you to check the QoS commands to check the current QoS and the partition settings. And the allocated GPUs are still referenced by the CUDA visible devices. If you are using GPUs on the TSCC1, probably you're already familiar with this environment variable. So the applications using the CUDA libraries will discover the GPU allocations through this variable. And please do not set the CUDA visible devices by yourself, but just let the job scheduler assign a value to this environment variable. And here are some other example application scripts available on the same shared examples on the TSCC. And as you can see, we have prepared many examples files for you to run. Please, if you are interested, just copy those examples to your own space and run from your own space. And just remember to modify the job scripts to use your own allocations or your own partitions or give some or the email address, your own email address based on your need. Okay, so after we submit and run the jobs, there are some SLURM commands for you to monitor your job. Please make sure once you submit your job and run your job, you should at least take a quick look about your job's status. Understand how much resources your job is using, for example. So to get more information about your job, the SQ command is the first command you should run to get more information about your job. So after you run this SQ command with your username, you can see how many jobs are submitted, are running, and which partitions the jobs is submitted to, and what's the status. And if it's running, you will see the R under the status, and how much time it has been running, and what's the time limit, and what's the node running your job. So you can get a very detailed information about your submitted and running jobs. Of course, if your job is submitted but cannot start, you will see a reason why your job cannot start in the SQ output. And if you wish to cancel your job, you can cancel your job with the scancel command. Just get the job ID first from the SQ command. And the next two command is I would recommend you to use to check your job status. The first one is the scontrol show job and then the job ID command. it will check the details of your job using the S control. The next one is SA count command, telling how how many times, how much time your job has run before it's finished. So those two commands are very useful, and you can even add those two commands in at the end of your job scripts. So once your job is finished, the output of those two job script those two commands will be saved in your standard output file. So you get more information about your job. So please monitor your job to pay close attention to the CPU and the memory consumed by your job. That's important to make sure you have enough resources to finish your job. Also, you are not wasting your group's computational resources. Oh, here are some commands you should try. The first is about the top command. Top command can be used on the compute node assigned to your job. Oh, that means you need to SSH to the command to the node running your job, and then run this top command. You will get a dynamic real-time view of your process. And you can also use the free command to check the memory usage. If you are using the GPU card, you can use the NVIDIA SMI command. When you have a job running on the GPU node, through the output, you can see if your program process is really using a GPU command, GPU cards or not. If it is using, you will find some process and the GPU numbers and IDs at the end of this NVIDIA SMI command to make sure that your program is actually using GPU card. Here are some useful SLURM environment variables, and of course not all of them are useful, or you should learn all of them. But usually, as I highlighted here, you can, once your job has started by SLURM, you will get those environment variables, and some of them I highlighted here, like the SLURM job ID and the submit directory, might be useful for you to check your job. For example, to give your SLURM job and output names, and for such job management purposes. So the SLURM job ID will save it's an environment variable that will save your job ID when your SLURM job starts. And the SLURM submit directory is an environment variable saving the path where you submit your job. So if you're a PBS commands user, you may find that every command you need to submit a job in PBS has a replacement in SLURM, and I just list the SLURM part compared to PBS in this table, and we can just have a quick review of those SLURM commands. For example, submitting a job, interactive job in PBS is qsub-I, it's an uppercase I, and in SLURM you use srun command. If you want to submit a batch job in PBS, you use qsub, your job script. Now in SLURM is sbatch, your job script. If you want to list your jobs and your node running your jobs, and you can use the qstat user -u user, and now in SLURM is sq. You want delete job, we have the same scancel SLURM command. And if you want to check your job status, remember to use the S control show job, and then add your job ID. And if you just want to check the availability of your of the node. Before we have a ls jobs command. Now in SLURM, you can just try the sinfo. The last one is how to get your allocation name. So before it's from the G balance, but now you can use the S account manager command to get the allocation name available to you. Okay, so that's all about the SLURM job submission and monitoring and job charging. What's happening next then? So we are preparing more trainings to help users get familiar with TSCC2. And each training will have most up-to-date information. And because this is an ongoing process, we're trying to add more up-to-date materials to our trainings. And still, the trainings will be focused on the storage, SLURM, accounting, software stack under the TSCC2. If we have enough time in those trainings, we will add more details, demos, examples, and benchmark performance. And meanwhile, during this testing period, we are starting moving the Condo servers to TSCC2, and we hope we can finish them in time. But again, your feedback is crucial. That will help us move the TSCC to the production phase sooner. Let us know if you have any questions or comments when you are testing TSCC. And here always we are here to help. And let us know if you have any questions through the email. And we also have our website available, but we are updating our website as well as the user guide. Please note we are keep updating them. So some of the materials might not be accurate, but we will try our best to improve. So that's what I have so far. Thank you so much for attending. Let me know if you have any questions or comments.
Yuwu, there are a few questions coming in the chat. I will read them out. One is, for job managers such as Nextflow or SnakeMake, can we manage it in the login node, or should we submit an independent interactive job, especially for pipelines that are very time consuming?
Okay, that's a very good question. I'm not a SnakeMake user, but I believe SnakeMake might be act the similar way with Nextflow. So when I was running Nextflow, in my workflow, I prepare some what I should say. I prepare something to let the pipeline submit the jobs by in the pipe to submit the jobs to the PBS or the SLURM. So that's what I did before with Nextflow. So that means once you run that pipeline, those time-consuming jobs or applications or programs will be done through a job. I mean, through a SLURM job or through a PBS job, if is still working in this way. So that should be good if you also have the same similar way to prepare your pipeline.
Thank you, Yuwu. Next one is, what is the expected timeline for us to fully move TSCC 2.0?
We expect we can move those stuff to all of the stuff to TSCC, including the nodes and the storage and the face problems in the next month or two. That's what we are expecting. But we don't have a determined date to say when this testing period will end or when the TSCC2 will be in production. I just my opinion, I don't think it's reasonable to give you a clear date at the moment, because it's very complicated project for us to to move those stuff, and many of the things were even new to try it. So, but in general, we expect the work can be done within in 1 or 2 months. Yeah, after 1 or 2 months. Sorry, it's not within, after.
Thank you. Next question is, does TSCC 2.0 have any advantage over the current TSCC for users? I am curious about the reasons behind this transition.
Oh, there are many actually. For example, the hardware, from the hardware side, we purchased the new storage new storage, as well as the network switch from our own funding, TSCC funding, or from the SDSC funding, and just upgrading those old hardware that have been in TSCC 1 for many years, and we are providing a new hardware environment for our users. We are also updating our middleware and software operating systems. As I mentioned, for example, the operating system now is Rocky Linux, which is very new and popular compared to the Central OS on TSCC 1. And we also have our new node management tools for managing our nodes. That's maybe you don't have a chance to use those management tools, but for us it's convenient to management nodes. So we expect to give less error when configuring those nodes, for example, or get an easier way to manage your nodes. That's another goal of our change. For the software side, we are updating our software. As I mentioned, we have a new software stack, as well as a very popular job scheduler in production now. So the SLURM is very popular and up to date. If you try submitting jobs to SLURM, you'll find that it's easy and fast to start a job. If you cannot start, it's easy to find why your job cannot start. So that's several advantages I can think of when updating to TSCC 2. My colleagues might have more to add, but I think there's a reason updating those things. There are many reasons. There's yeah.
Thank you, Yuwu. A follow-up question regarding the Nextflow is whether the Nextflow itself could be used on login node, as it will be running all the time in the background submitting jobs.
And as long as your pipelines are using jobs, I mean, are submitting jobs before running those programs, I think it should be good. I mean, once it's configured, and your pipeline are prepared, make sure when running those stuff, those time-consuming applications are using using a compute node or GPU nodes to run. So that's my point, because if you have a Nextflow and you have a Nextflow pipeline, but you do not submit jobs in the pipeline, then sounds like your program or applications will be run on the login node. That's not a good idea.
Thank you, Yuwu. Next question is, can TSCC 2.0 nodes communicate with hosts on campus networks that are outside of the cluster network?
How to communicate? could you specify or give us some examples how would you like to communicate with the campus network?
Yeah, sorry, that was me. So basically we have a tool that you can add clusters into it to submit to those clusters, but then the software it has to run on the compute nodes will try to talk back to the central web service. So I just wanted to check if we ran that web service on a server that's, say, located on a different UCSD network, if we could run jobs through TSCC that could then communicate back to that web service.
The first thing comes to my mind is whether the IP will be added to the whitelist of that server, or your IP address is allowed on our side. That's the thing. And sorry, I'm not a network expert, so I might leave this question to my colleagues who knows about this, and hopefully they can answer you now. But if not, I will follow up with you.
I might be able to help you with that. Hey, Brendan, it's Todd. Let's talk about that and see if we can help you out offline.
Okay.
All right. Awesome.
All right.
Brendan's a friend of mine. I know who he is. So.
Thank you, folks. Next question is going to be, if I need to run jobs that will take 1 to 2 months to finish, should I wait to run them after the transition? Is there any risk of migration while jobs are still running?
That's a good question. For now, we do have time limits. So we for on the TSCC2 side. So it's unlikely that there will be a job that can run for 1 or 2 months. Even if you submit to, if you are a Condo user, you are able to submit to the Condo. I haven't tested how long, but the jobs in the submitted to the Condo are preemptible now. So after 8 hours, your job might be subject to preemptible to preempt, and that means your job might be canceled after 8 hours in Condo. Meanwhile, we also have a time limits on the hotel, and that's a good question. So if you're again, also you're running a job like a 1 or 2 months job on TSCC1, you should keep running now on TSCC1. We don't have a mechanism to transfer your PBS job to a SLURM job and make it keep running on in SLURM. What you have what you have started on TSCC1 has to keep running. I mean, we don't, or unless your job there's some checkpointable mechanism in your program that can stop, and then you move your stuff to TSCC2 and running. I don't know. It doesn't sound really good to me like that. Sorry.
Suba, I see your hand up. Do you want to chime in?
Yeah, I was just going to jump. So I have a question for Nicholas. Are you saying that you just want to use your node for 1 to 2 months and you have multiple jobs to run? Or as you was saying, we assume that it's not just one job that you require a month to run, right? But one thing we can do is, we can work with you to see when you want to move your nodes, if maybe earlier, so you can continue running on TSCC2. So we can definitely contact you after this and figure out what's the best way.
Hi, Suba. Yeah, thanks for that. Yeah, I pretty much run exclusively month-long jobs pretty much right now. So If that's going to be an issue moving forward, then we should probably discuss.
Yeah, we can discuss. But like you said, there's always an option to checkpoint restart, not just this, even in for the TSCC 1 or 2, it doesn't matter. Just because 1 month of guaranteeing a system, for a job to run, if there's an interruption, your job will fail, right? So we can explore that. We can help you with that.
Yeah, absolutely. Thank you.
Thank you both. Thank you all. So the next question is, I understand that there is no set date for migration, but will each group / home-q be notified in advance when our nodes will be migrated? Or how much interruption should we plan for?
To answer your first question, yes, we will notify your group when your nodes is added to TSCC 2. Yeah, that's my job. And when it's done, I will notify your group and encourage your group member to try your nodes on TSCC 2. Regarding the interruptions, if you are talking about the possible downtime, we based on what we are doing now, we schedule a 1 day of downtime when moving. We are scheduling a 1 day of downtime for each condo group, and then if everything goes well, we will, after the downtime, we will see the nodes on the TSCC 2 side. If that's the interruption you're asking, or if you're asking the similar question about you have a long job, like running for 1 or 2 months, and how they likely to be interrupted, they will be interruption for those jobs, but we can review those long jobs to see how they can be affected.
Hey, Yuwu, this is Xiaoxu. I was asking about the Nextflow snake-make questions. So the question I actually have is, if I'm just running the snake-make, like what I'm doing now on the login node. So if it's just submitting jobs and managing the jobs, it won't get killed from the login node, right? Because all the actual jobs are still running on the compute nodes. I'm just using a several days, several week snake make to managing those jobs should be fine, right?
Yeah, that's the baseline is your snake make pipeline is not using too much computational resources on the logging node.
Okay.
If not, then that should be fine. Yes, a similar case is the Galileo. As you may heard, the Galileo we are using, which is a tool for starting Jupyter Notebook.
Yeah.
On the compute node, but once the Galileo has started, Galileo can be run on the logging node directly. Once it started, the Jupyter Notebook will be on the compute node. So any computational computations will be on the compute node. So
I know.
that should be fine. Yeah.
There is not a time limit on that, right?
There's another time limit for that.
There's no time limit on that, right?
There is. There's for TSCC 2. I mean,
for the login node.
For the logging node, no, of course not.
Okay.
But your job has the
I know.
has the limit. Yeah.
I'm just afraid that if my snake make take a lot of time to manage the job in the background and they on the login node they get killed. But I mean it will be very similar to what I'm doing now, right? On 1.0, right?
Right.
Okay.
It will be very similar. I'm not aware of any process termination termination because it's on the login node.
Okay, thank you so much.
All right, your next question is, how long will TSCC 1 still be available?
Yeah, that's a very good question. I would expect it will still be available for some time until we have confidence that your jobs or your staff have been more transferred or can start smoothly on TSCC2. So for now, at least for the next one month, TSCC1 will be available. That to my understanding, yeah. And but still, sorry, I don't have an exact date when TSCC1 will be cut off. So that's too hard to answer. But we should expect that TSCC1 will be online for some time, at least one or 2 months.
So does it mean that after the compute nodes are also mounted to 2.0, both 2.0 and 1.0 have access to the same condo nodes?
Oh, the condo nodes once moved to TSCC2, it cannot be accessed from TSCC1. That's for sure. So, but I'm talking about other stuff like the projects directory or some files in your TSCC1 home or Scratch. They might be available still on the TSCC1 when TSCC2 is in production.
Well, project should be mounted on both, right?
The projects my colleague can correct me if I'm wrong, but the project storage can be mounted on both sides. I mean, both TSCC1 and 2. It's what I can see for now. But once we think it's time, we will just unmount the projects directly on TSCC1. So you can only access the project directly on TSCC2.
Okay, thank you.
You're welcome.
Maybe I can just chime in a little bit just to clarify, Yuwu. So, once we move your nodes over to TSCC2, we mount your projects there, pretty much you will run, your jobs on TSCC2. We will still have the one open just in case if you have your files and you still need to copy. And that's the only reason. There will be no access to your nodes on both the sides. It'll be just once we make your move, it'll all be on the TSCC2 where you'll start running.
Okay, thank you. So yeah, probably we have to make sure, I mean, similar to the long time jobs that we're talking about, probably have to make sure the limits for the queue first before we decide to fully move all our compute nodes, right?
Yeah, our system before moving your nodes, our system admins will examine if there are such long time jobs from your group, and if they are, we need to discuss, or they will pay attention to those long time jobs. That's what I know so far, and they will take proper actions to deal with it.
Thank you, Yuwu. Let's see. Question answered there. Okay, the next one is someone's wondering what the command is to use for Galileo.
Oh, what is the command to use Galileo? It's still Galileo. it's still the Galileo command to use Galileo. The thing is, at the moment, we haven't installed Galileo system-wide, but you can, if you want to try Galileo right now, you can install one in your own space and then start Galileo. And one of our users has helped to try this before, and it seemed to work.
Thank you. I hope that answered your question. And then the last one that I have here is, would you be giving an advance notice when TSCC 1 is no longer available?
No. Yes, we will let our users know when TSCC 1 is no longer available. For example, when their allocation, TSCC 1 allocation will be zeroed out, because they now their new allocation and nodes are on the TSCC 2, and we are notifying users about this. But if there's a whole if there's a node sent to everyone that the TSCC 1 is offline, I'm not sure if we will have that. Shuba, if you're here, could you introduce such, if there's such plan for announcing TSCC 1 will be offline to a certain date?
We don't have a date yet, but yes, when we are going to cease operations, we will notify, all users.
Okay. Right.
All right, before we wrap up, if there's no other questions, thank you very much for being with us today. Thank you for our speakers and our TC support team in the back end to help answer questions. Again, if you have any questions, email that support email that's in the chat, and thank you very much for joining us.